Okay, good morning class. So today we're looking at probability. Now last lesson we spoke about the arrangement of objects in a row. Now we're looking at the reading for today would be letter arrangements where letters are repeated. This is for exercise 4 on page 319. Okay. Even the example, we're looking at example 11, which is on page 317. Okay, I made the markings already. The full lessons can be found in the description box below. Okay. So in example 11 we are told consider the letters of the word dad. How many word arrangements can be made with this word if the repeated letters are different letters? Okay. What do they mean then? Okay, as you can see, yes, 2 D's. Not so. So, are all the D's the same? Yeah. In this case, repeated letters, which is the 2 D's, are different letters. Basically, it's not the same. That's what they say. You guys understand? So, if I write that out, the first arrangement can be that, if that's D1, D2, because here we have said that the D's are different. Another way I could have written this is D2, A, D1. How else can this word arrangement be arranged? A double D is 1 and 2. A double D, 2 and 1 of course. Double D, A, and D2, D1A. So how many word arrangements are there? There are 6 word arrangements. So of course we are not going to do that all the time. Okay, so we need to come up with some short annotation or a simpler calculation. So from here, if it says that how many word arrangements can be made with the word, if repeated letters are treated as different letters, then how many options, how many bits should I have? 3. Can you see that? So how many options do I have here? 3. Then 2. Then is the same as 3 factorial, which is 3 factorial, which is of course 6. Okay. You all agree with that? Any confusion thus far? Now, if I look at if I look at B now, here we are told in how many word arrangements can be made with the word if the repeated letters are treated as identical letters. Repeated letters are treated as identical letters. So are the D's the same in this case? This was identical. Alright? So how many word arrangements can then be made? Is DIDS, D, sorry, double DAS, A double D. So any other options then? So any other options that can be arranged? No? So how many outcomes are there? Yeah, 3 outcomes. Now if you say, okay, how does factorial, how can we apply factorial here? You might say, okay, how many bits would we have here? 3 bits. So it's 3 letter words we make it. How many options do I have for the first case? Of the 3 letters? 3. Then 2. Then 1. Sorry? 3 to 1. But 3 times 2 times 1 is 3 factorial. And 3 factorial is 6. But yeah, I got 3. So how are you going to get from 6 to 3? You're going to divide yes by 2. So, if I look at that, so yes, it's going to be 3 factorial divided by 2 over 2 factorial. Not so. And 3 factorial divided by 2 factorial is 3. So where do you think this 2 is coming from? From the D's. Can you see as 2 D's? So I'm dividing it by 2 factorial. Okay. That's where the rule is going to come in now. The rule 4, which is you guys can write this down as well. We are told that the number of different ways that n letters can be arranged, where m1 of the letters are identical, m2 of the letters are identical, m3 of the letters are identical, and so on, all the way to m to the m of n of the letters are identical is given by n factorial over m1 factorial times m2 factorial times m3 factorial, and so on, till n, where the repeated letters are treated as identical. So if they tell you that the repeated letters are identical, this formula should pop up in your mind. Okay. The pause here quickly. So let's look at another example. Example 12. Show on the next page. We all want to feel like this at times, no? No. Needed. No. Otherwise we feel useless, no? 318. So consider the letters of the word needed. The first question says, how many word arrangements can be made with a word if the repeated letters are treated as different letters? So again, that is are same or different? Different. And the D's? Different. So, if I'm going with the fact that there are different letters, do I apply the formula? When do I apply the formula? The repeated letters are treated as identical. That's how I distinguish which. Do I apply the formula or not? Okay? So how many bits would I have here? 6 bits. As there are 6 letters. So how many options do I have for bit 1? 6. Bit 2? 5. Bit 3? 4. 3, 2, 1. Which is the same as 6 factorial. And 6 factorial is 720. Okay? So any confusion? Easy, no? Okay, then then everything in maths again is easy. No? So let's look at B. How many word arrangements can be made with a word if the repeated letters are treated as identical? Do we apply the formula here? So what's the formula? N factorial over M1 factorial times M2 factorial times M3 factorial all the way to Mn factorial. So what is n factorial? What is n? The number of letters, which is 6 factorial over. M is now the repeated letters, not so. So how many e's are repeated? 3 e's. So it's going to be 3 factorial. How many d's do I have? 2 d's. Which is 2 factorial. You guys understand? I can't make it simpler than what it is, okay? So it will be 6 factorial, 6 factorial over 3 factorial times 2 factorial. Gives you 60. Easy. Huh? See any confusion at this point? So let's spice up your life a bit. Of course, you can't leave life to be so easy. So plain, shouldn't say easy. Plain. Okay. Remember what word we're looking at? Okay. So now we are told that how many word arrangements can be made with a word if the word starts and ends with the same letter? Starts and ends with the same letter. So what does that mean? How many birds would I draw in the first bit? Huh? 6. 1, 2, 3, 4, 5, 6. Start and end with the same letter. What does that mean? Start with an E and end with an E. Not so. Starts with an E and end with an E. Okay. So here we are again going to look at the repeated letters are treated as identical letters. So they didn't say so. Okay. Normally after that question where it says that, then I know it is considered repeated letters are treated as identical. Then I know I must use the formula again. Okay. People, if I use the E and the E, what are we left with? N, D, E, D. Not so. How many options do I have here? 1. It can only be an E. Not so. How many options do I have here? 1. So what are we left with? There are 4 letters, 4 factorial over. How many repeated letters are there? There's 2 D's. Not so. Remember what is the rule? Is n factorial over m1 factorial times m2 factorial and so on. So we are looking at these 4 letters, so it's 4 factorial. Okay? Over, and there's 2 letters repeated, so it's going to be 2 factorial. Okay, so that's simply 4 factorial over 2 factorial. Whatever it is, no? I think it's like 12 or something. Okay. But, yes? So, oh, it is, that's where I'm getting it. But, so you want to start with a D, not so. You all agree with that? It could start with a D and end with a D as well. Now what? If that is the case, what are we left with? Our D's are out. Then we got N, E, E, E. Right. How many options do I have here? One. Yeah? One. How many letters are we left with? 4 factorial. Over 3 factorial. It simplifies into 4 factorial over 3 factorial. But they haven't answered the question. What is the question? How many word arrangements can be made? Can you see that, people? So my total is simply going to be, my total is going to be 4 factorial over 2 factorial plus 4 factorial over 3 factorial. Punch that in the calculator. Get 16 such cases of combinations. Okay. Any issues there? No? Right. Example 13. And we all want one of these in our lives, not so? Huh? No. No knight in shining armor? What do you then want? Alright, rather leave it there. Alright. People, consider the letters of the word knight. This is now, of course, 13. Which page is on? 318. 319. Okay. Consider the letters of the word knight. How many word arrangements can be made with the word? With this word? The letters are not repeated. Do we use the formula here? When do we use the formula? They are identical if it's the same. So how many bits should I draw here? 6. 1, 2, 3, 4, 5, 6. How many options do I have here? 6. Then 5. Then 2, 1. Which is 6 factorial, which is 780. Right, you guys understand? B. Remember when we wrote down this rules, when we spoke about factorial and introduced factorial, what did we say 0 factorial was? 1. Okay. You can test it as well. It is 1. So the question says, remember we're using the word knight. How many word arrangements can be made with a word if the word starts with a K and ends with a T? Okay? So here we are treating the repeated letters as identical letters. Okay? As you can see, it's not specified here. Okay? So, what is the formula when we use the fact that repeated letters are treated as identical letters? N factorial over M1 factorial times M2 factorial times M3 factorial and so on. Okay. So what do we have? 1, 2, 3, 4, 5, 6. It must start with a K and end with a T. What are we left with? N, I, G. Okay, I'm not going to say the word. Okay. Right. So what do we have? How many options do I have here? 1. Here? 1. Okay. So how many letters are left? 4. So it's 4 factorial over. How many repeated letters are there? 0. 0 factorial. Okay, and then of course this you can put in a calculator. 1 times 4 factorial over 0 factorial times 1. And answer 20. People, you guys understand? Is there any confusion? So with that, your homework is going to be, of course, exercise 4 on page 319. Okay.